Today we are solving mathematics paper for grade 8 ICSE Pro Learning Academy FP series FP03 dated 9th March 2024. We start with MCQs. We have 15 MCQs and we will solve each of them. So the first MCQ, it says in quadrilateral ABC, the angles are in the ratio 1:2:3:4. Find the difference between the largest and the smallest angle. So if you have taken the common multiple as x, the largest angle will become 4x and the least angle will be 1x. So if we add these ratios, 4 and 3 makes 7, 7 and 2, 9 plus 1 is 10. So we know 10x is 360. 10x is 360. Therefore, x is 36. So the smallest angle is 36 degrees. The largest angle is 36 times 4, which is 144 degrees. The difference between them is 108. 108 is the answer. The next one, it says if set A is this. Here there are two important things. N is less than or equal to 2, it says, and n belongs to whole number. Our variable x is given in terms of n. So here we will be able to feed in place of n as only three numbers, 0, 1 and 2. So there are only three numbers that we can feed in place of n. So the number of elements in this set is going to be 3, and it is asking us the cardinal number of the set it should be. So here the answer will be just 3. So there will be 3 elements in this set. We go to the next one. The rate at which Arjun spins the basketball is dash to the force applied by his hands. So we know here physics is applied, but this is also mathematical brainstorming. So the more consistent you are in terms of keeping that force intact, the ball continues to move on and on. So this is directly proportional. So here we have directly proportional. The literal factor of the polynomial. So we know if you want to factorize this polynomial, we will get 3x out x minus 5. So there are three factors here. We know 3 is one of the factor, x is the factor, and x minus 15 is the factor. So here in this case, we can safely consider x as a literal coefficient, which means a letter or a variable, and 3 is the numeral, not the coefficient, rather the factor. 3 is a numeral factor. So here we know our answer is x. X is the literal factor. If a fair dice is thrown once, dice has got numbers 1, 2, 3, 4, 5 and 6. If it is a fair dice, each of these numbers have got equal chances of occurrences. So the chances of any number appearing on the top face is, here it is obvious we are expecting 1, 2, 3, 4, 5, 6, any of these. So the chance that we will have for each of these number will be 1 over 6. So D is the correct option here. If the compound interest is compounded yearly for a period of 2.5 years, then the period for the compound interest computation, here it is saying computation, it is asking us period. For example, if the question says the compound interest for 2 years and it is compounded yearly. So if it is yearly, in 2 years there will be 2 periods of 1 year each. If it is half yearly, 6 months is defined as 1 period. So in 2.5 years, we will have 5 periods. So here we know our correct answer is 5 periods. Now here it says if the spinner is marked with 0, 1, 2, 3 and goes up to 9, which means we have got 10 options here where the pointer could rest, then the probability of the spinner pointing at a number which is divisible by 3. So here we know the numbers which are divisible by 3 are going to be 0, 3, 6, 9. So we know we have got 4 favorable outcomes out of 10. So 4 over 10 is 0.4. So whether we write 0.40 or just 0.4, it doesn't make any difference. So this is the answer. The color of the human hair is dash data. Here it is qualitative data because it is speaking about some quality. It isn't quantitative. Quantitative is only when you have your answers in numbers. It has to be numbers. For example, I ask how many students are there in class 8? So we will get the answer as 10 students or a 5 students. So here there is a number that comes into picture. So then it becomes quantitative data. If we move on to the next one. So the answer for this one, that is the eighth MCQ, was qualitative data. 9. If a set A has got elements 1, 2, and set B has 1, 2, 3, then set A is dash of set B. So here in this case, two answers could be right here. This subset or a proper subset. But to be more specific, the correct answer is proper subset. So proper subset is more specific. Subset is just, it could be considered as one of the correct option. Here we will go with proper subset. Here the question says the diagonals of the square they are equal to each other. Yes, that is the case. Bisect each other at 90 degrees. So the diagonals of the square are perpendicular bisectors of each other. So even this property holds true. The diagonals bisect opposite angle. 90 degrees gets bisected into 45 each. So here in this case, all of the above is the correct answer. All of the above is correct answer. We move ahead. Now the question here is the range of the data. The data starts from 11, 12, 14, 18, 30, 32, 35, and 4. The greatest value is 35 and the least value is 4. So range is greatest minus the lowest. 35 minus 4 makes 31. So our range is 31. The range of this data is 31. If one man's work is equivalent to 4 boys' work, so one man's work is equivalent to 4 boys. 4 boys' work. 4 boys' work. It technically means if you replace one man with boys, so 4 boys would be required for the same execution of the work. So here the question says 10 men can do a piece of work in 4 days. So we have 10 men can do the piece of work in 4 days. And how many boys would be required to complete the same work in 4 days? So here we haven't changed the number of days, we haven't changed the work. So technically 10 men, one man was 4 boys, so 10 men will be 40 boys is the right answer. 40 boys is the right answer here. Here it says if cardinal number of set A is 9 and cardinal number of set cardinal number of set A is 16 and the cardinal number of set B was 9. So here we want to represent these two sets with these circles because circles are used to represent the sets and the rectangle is used to represent universal set. Here in this case it says cardinal number of set A is 16. So we know A is 16 here. We know cardinal number of B, that means there are 9 elements in B, so we write it here. It says under which conditions is the cardinal number of set A union B would be 25. So we know cardinal number of A union B is cardinal number of set A plus cardinal number of set B minus cardinal number of A intersection B. So here we're expecting the union to be 25, so feeding 25 here. Here in this case, we have got A is 16, so we write 16 here, plus 9 here, and minus, which we don't know, A intersection B. So if we move the A intersection B on the left, therefore, cardinal number of A intersection B would become 25 minus 25 is going to be 0, which means we are certain now that there's no intersection. These two sets are disjoint sets. So this kind of a possibility is going to arise when there's nothing in common or the two sets are disjoint sets, if and only if A and B are disjoint sets. Here the question says, the 14th one, the sum of the exterior angles of a regular nonagon. Let there be n number of sides. N could be 3, n could be 30, n could be any number. For any polygon, whether it is regular or not, sum of the exterior angle is always going to be 360 degrees. So here the only correct answer was 360 degrees. Question number 15. Here, if x is 5 and y is minus 3, then the value of under root x square minus y square, x square becomes 25, minus 3 the whole square makes 9. 25 minus 9 makes 16. 16. So here we're looking at 25 minus 9, which is root of 16, which is obvious 4. So our correct answer here in this case is C. So we have the correct choice as C, which is 4 here. So that takes care of our MCQ bit. Now we move on to solving the questions here. It says if the diagonal AC and BD of a rectangle ABCD, so we take this rectangle down here. We know that ABCD is a rectangle, so ABCD is a rectangle. The diagonals AC and BD intersect at O. So we know this diagonal and this diagonal, they're both intersecting at O. The other question says if OC is 2x plus 3, if OC is 2x plus 6, and BD is 6x plus 6. So this is 6x plus 6 is the whole of the BD. So we know that the diagonals of the rectangle, they are equal and bisect each other. So we will write these two properties here. AC is equals to BD. We want to write AO is OC is half of AC. For both these, the same property applies. Diagonals of rectangle are equal and bisect each other. Bisect each other. So here we know that AC could be written as 2 times OC. So third statement is therefore AC is 2 times OC, which is going to be 2 times 2x plus 6, which is 4x plus 12. Since the diagonals are equal, is already stated in statement number 1, so we want to straight away jump to our working. So 4x plus 12 is 6x plus 6. The reason for this is from statement number 1. So here we have to operate this. So 12 minus 6 is 6x minus 4x. So 6 is 2x. Therefore, our x is 3. We can't write x is 3 centimeters. X is just going to be a plain number, which is 3, because x is not completing the diagonal. The diagonal is 2x plus 6. Now, the second part that it says is find angle DBC. So here we are interested in finding the angle DBC. Move it little here. All right. So the second part is find angle DBC. And there's ABD is given. So ABD, this angle of ours is 42 here, 42 degrees. We are interested in this angle. DBC is a question mark. So since we know that each angle of a rectangle is 90 degrees. So here you want to say angle ABC is 90 degree. Each angle of rectangle is 90 degrees. Therefore, we will say angle ABD plus angle CBD is 90. Therefore, 42 plus angle DBC, which is DBC, is 90. Therefore, angle DBC is 90 minus 42, which is 48 degrees. So we have solved question number 2. Here it is most important that we write the properties. So we have used a couple of properties, that the diagonals of the rectangle are perpendicular, not perpendicular, they are equal and they bisect each other. And here each angle was 90 degrees, so we have made use of each angle is 90 degree as well. So we continue solving further. Here we have question number 2b. It says a letter is chosen from the word random. So first we are required to write sample space or all possible outcomes. When we do our solution, we'll write the sample space. We are writing sample space. Our sample space in this case is R comma A, that is N D O M. Now here it says find the probability of getting a vowel. Find the probability of getting a vowel. So we know here the vowels are A and O only. So the first one we want to go with. So vowels is A comma O. Therefore probability of an event is number of favorable number of favorable outcomes upon total possible outcomes could be written as M over N. So the purpose of us writing this formula and writing M over N is each time we don't need to write the formula, so we will continue using M over N. So therefore we will say probability of getting a vowel is M over N, which is 2 over 6, which is 1 over 3. So the first one is taken care of. We move on to the next one. In the next one, we need consonants. So consonants, we have consonants is going to be, how many consonants we have? We have R, comma, N, D, and M. Now, since we know this is 4, so we will write probability of getting consonants is M over N. M is 4, favorable outcomes is 4 over 6, which is 2 over 3. Now, in this case, there is another way of solving this consonant part as well. So we will try solving that as well. The alternative method. The alternative method for us is, here in this case, probability of getting consonants is 1 minus the probability of vowels. 1 minus probability of getting vowels. So since we know in English letters there are only two possibilities, either it could be consonant or the vowels. So probability of the consonant plus the probability of vowels is always going to be 1. So that is the reason we are able to use this. Such events are said to be disjoint events. Whenever the events are disjoint, so let's say A and B are two events where they are disjoint, there's nothing in common. So in this case, probability of A plus the probability of B is going to be 1. So that's the reason we are able to use this particular approach. So that becomes 1 minus 1 over 3 will become 3 minus 1 over 3, which would be 2 over 3. And this answer is precisely matching with our answer that we obtained at the top. The answer that we have obtained at the top. This and this is the same. Now we move on to the third one. The third one says is not the letter of the word mod. So here in this case, we continue solving here. So we are saying not the letter of the word mod. So third piece for us is not the letter of word. MOD. MOD. So our favorable outcomes would become R comma A comma N. So here in this case, we are looking at probability of not the letter of the word mod. Probability, since I don't have space, not the letter, not the letter of the word mod is again m over n. We have got 3 over 6, which is 1 over 2 is the final answer here for this. So we have broken this into 3 parts. So here the elements that are needed here, the sample space is a must, favorable outcome is a must. You write the formula once and then continue solving. So your final answer must be in reduced fraction form. So 1, 2, 3. That is done. We move on to the next one. Here the question says an empty cistern can be filled by two pipes A and B in 12 minutes and 16 minutes respectively, and the full cistern can be emptied by pipe C in 8 minutes. So there are three pipes, two are responsible for filling and one is responsible for emptying. If all three pipes are turned on at the same time, in how much time will the empty cistern be full? So we are required to get for in 1 minute what each of these could do, the filling rate and the emptying rate. So this is pipe A, since it is able to fill in 12 minutes, pipe A fills in 12 minutes. Therefore, in 1 minute, what it could do? In 1 minute, it fills 1/12. It fills 1/12. We will go to the second piece as well. Since this was for pipe A, we are moving on to pipe B. So let me just rectify this spelling. So we have spoken about pipe A. We will move on to pipe B, and then we will have to move on to pipe C as well. So instead of fill, it will be empty. These numbers need to change. Fills 1/12. So here we knew it was 16 minutes, so we write 16 here, 16. So this becomes 1 over 16 in 1 minute. So pipe C, instead of fill, it is empties. So empties, empties in 8 minutes. Therefore, in 1 minute, it empties. How much will it empty? It empties, because it was 8 minutes, so it should become 1/8. So we have 1/8 here. So we are now interested in how much time will the empty cistern be full. So we are looking at what three pipes could do simultaneously in 1 minute. Therefore, in 1 minute, net filling, net filling of the cistern is 1 over 12 plus 1 over 16 minus 1 over 8. So we know we will have to work with LCM. So we know LCM is going to be 68. So 12 times 4 makes 48. LCM is 48. So 12 times 4, 1 times 4, 16 times 3, 1 times 3 here, 8 times 6, 8 times 6 is here. So this looks like 4 plus 3 minus 6, the whole over 48. That becomes 1 over 48. So we now know, therefore, in 1 minute, 1 over 48 at cistern is filled. Therefore, whole system, 1 represents whole, in how many minutes? That's a question mark here. So we know this is a direct proportion. So we could continue solving here and we would get therefore whole system fills in how many minutes? We will write we get what we get is 1 times 1 over 1 over 48 is 48 minutes, is 48 minutes. This piece, what we have just done here, it becomes very good when we have expressed this, because it gives clarity how we got the answer as 48. So here we will have to say in how much time will the empty system be full. Therefore, empty system will be filled in 48 minutes. So for every word problem, answer statement is a must. Is a must. Doing undo here, 18 minutes. So the answer statement, you should not leave any scope for evaluator to be cutting our marks, because we should take care of our 1 mark here. We move on to the next part here. So this was our solution. Here also we had solutions. So here we have solution. We continue further. Question number 3 says factorize. So what we will do is we will make 2 places here. So we have the first piece. Here if you look at them, 1, 2, 3, 4, 5, 6. There are 6 terms. So here we can make group of 3, 3, or we can go with groups of 2, 2. So let's try with groups of 2, 2. So we're looking at this particular pair. Then we are looking at from here we will get a minus 3. So our hope is that we get a minus 3. So we will look at this and we will look at this as well. So by looking at the first term, what we get is our solution is a square is out, a minus 3 plus 2 is a common factor out, a minus 3. Your minus b is a common factor out because you have to maintain a positive, so minus b. Minus and b is out, so we will get a as the element which is left inside, a minus 3. The reason for this is minus times minus becomes plus, so that is how this becomes plus 3b. So now we know we have got 1, 2, 3. These are identical elements. So we will write is equals to a minus 3 as one common factor out. This is a square plus 2 minus b. This is the final answer for our factorization. Final answer is here. So we are highlighting this. Now here in this case, we should evaluate whether this is further factorizable or not. Here it is not factorizable. So we will not do anything further in this case. We will not do anything further here. So we go to the next one. Here there are 3 terms, but we can easily break these 3 terms into 4 terms. So we are expecting that either we get 4 terms or 6 terms. Because if it is just 3 terms, the only thing that can be done is you can pull out common from all the 3 terms, but here that is not obvious because there is a square here, a, and there is no a here. So we will try to convert this into 4 terms now. So that is only possible because when we open this particular bracket of ours. So let's continue. So we have a square minus ab minus 5 times a plus 5b. First, let us evaluate. From here, if we pull a out, we'll be left with a minus b. From here, if we pull minus 5 out, we'll be left with a minus b. So our approach is right. So we continue solving this further. A is a common factor out, a minus b stays in. Minus 5 is a common factor out, a minus b stays in. So we have a minus b times a minus 5. So we have successfully factorized the second one as well. So our factors is complete here. Now again we have got algebra question. Here in this case, cross multiplication is the key because this is a monomial, a single fraction here, single fraction here. We should go ahead with cross multiplication. The only thing that we should be careful is about this minus sign here. So we continue our process. Therefore, 2 times 3 plus x is minus 1 times 2x minus 3. Since we know multiplication, their distributive property of multiplication will apply, which means minus 1 will multiply with 2x and it will multiply with minus 3 as well. Here the same thing happens here, 2 times 3 and 2 times x. So distributive property we use in here. So therefore we get 2 times 3 makes 6 plus 2x is minus 2x plus 3. So we're going to pull all the x's together and the numbers on one side. So 2x plus 2x is 3 minus 6. 4x is minus 3. X is minus 3 over 4. Since it is a proper fraction, so we can leave it as minus 3 over 4, or we can write therefore x is minus 0.75. We can leave this answer here. Absolutely fine. So here this was therefore here. So we can leave the answers either this or we leave our answers here. Since it is easy number, so we continued solving here. We move on to the second one. Second one, it has got 3. That is trinomial on the left and just the number 1, it is equated to number 1 on the right. So the best approach in this is, here the denominator is 2, 4, 3 and here it is 1. So we know 1, 3, 2 and 4, the LCM would become a 12 because 3 times 4, because 3 factors are 3 and 1, 4 factors is 2, 2. So the least common multiple is going to be 12. So here in this case, we are looking at multiplying each of these terms with 12. So let's multiply here and just show it times 12 here, times 12, or rather we could copy it down and we could do it so that we have more space. So here we have copied it here, we make little more space and we are multiplying each term with 12. So we can easily show that multiplication here. So we're multiplying this with 12. We are multiplying this also with 12. We are multiplying this term with also 12 and this one also with 12. So each of these terms are multiplied because it was equation. We have done it on either side. So mathematically it is balanced. So now we know this will be 2, 1, 2 times 6, 4, 1, 4 times 3, 3 times 1, 3 times 4. So now we have the plain equation would become 6 times x plus 1 plus 3 times 2x minus 1 plus 4 times x plus 2 is 12. So we continue further, which is therefore, we will write therefore 6x plus 6 plus 6x minus 3 plus 4x plus 4 times 2, which makes 8, minus 12 would become 0. So here we know 6 and 6 makes 12 and 4 makes 16. So we have 16x here. 6 and 8 and 6 makes 14. 14 minus 12 makes 2. 2 minus 3 makes minus 1. So we left with minus 1 here, which is 0. Therefore 16x makes 1. Therefore x is 1 over 16. X is 1 over 16. We continue solving this further. Here in this case, again, this is a set builder form, which is the rule method. Here we are required express the set in roster form. So we will be required to get the roster form of this particular set here. Then the cardinal set, it should be cardinal number of set A. So we are continuing with cardinal number. I'll replace this as cardinal number. This is number. So cardinal number of set A. First preference should be we do this. So D part is taken care of. Most of the things will be taken care of. So we are looking at solving D. So we are looking at the solution. So here n belongs to natural numbers. So n is less than or equal to 6. N values could be 1, 2, 3, 4, 5, 6. These are the 6 values that could be taken in place of n here. So 3 times 1 is 3 minus 2 makes 1. So my set A cardinal number would become I could do a bit of a rough working, or maybe in the main area. Rx will become 3 times 1 minus 2. So that is 1. Okay, my x will become 3 times 2 minus 2 would become a 4. This is when n is 2. N is 2 here, n was 1, n is 3. So Rx is going to be Rx is going to be Rx is going to be 3 times 3 minus 2 makes 7. When n is 4, Rx would be 3 times 4 minus 2. That would make 10. When n is 5, Rx would become 3 times 5 minus 2, that is 13. When n is 6, x would become 3 times 6 minus 2. So 6 is 18 minus 2 makes 16. So we have these elements. So we are writing the elements that we figured out. So we know our first element is 1, 4, 7, 10, 13, and 16. These are the elements that we have figured out. So now it is quite obvious that there are 6 elements here. So the cardinal number of set A would become 6. So we are writing A. Therefore, cardinal number of set A is 6 is done. Here, this question says 18 and there is set A. So ideally, if there was some subset, maybe there was a set. In this case, only if we had one more set, maybe set B, and B had elements 1, 4, and 7. So in this case, we would have said that B is a proper subset, or rather, B is a subset of A. But here they are not talking about a set; it is just an element. So whether you will have to check whether this 18 is present in this set or not. Since it is not there, so we will say 18 does not belong to set A. So our B answer is, therefore 18 does not belong to set A. Set A. That is B. So we go to C now. The number of subsets of set A. So we know number of subsets. The formula is 2 raised to the power n. Here n is number of elements. So 2 power 6 would make 64. So 64 subsets possible. Therefore, 64 subsets subsets are possible. We move on to the next part here. Question number 4. Section B has 4 questions. Out of the 4 questions, you are required to do 4. So you have to make the right choices and do it. Here we will do all the 5 questions from this section, because you have got 5 questions in this paper. It's saying factorize. So when we're looking at factorize, we identify the terms that we're talking about. So 1, 2, 3. So it's a trinomial. So first thing that we need to do is we need to check whether some element is common in all of these sets or all of these terms or not. So here it is quite easily identifiable. A minus B. Here also is A minus B. Here instead of A minus B, it's B minus A. Just the signs are reversed. So what we want to do is, from this bracket, we want to pull -1 as a common element out. So this would look like our solution is here. So we have x squared times A minus B minus y square times a minus b plus z square times, instead of a plus z square, we want to do a minus 1 z square, and instead of a minus a it would become a plus a, instead of a plus b it becomes a minus b. So we have easily identified now that this element here and this element here and this element here, these are identical brackets present here. So we will pull them out. So this is a minus b is out. We're left with x square minus y square minus z square. So here beyond this nothing else is possible, because here we can't do anything. Because even if we were looking at the difference of the square identity, difference of the square identity could be applied only if it was this much. Or maybe x square was not there and the question was this piece was not there, this was this with this. Then in this case, the difference of the square identity could be applied. That is y square minus z square becomes y plus z and y minus z. But here in this case, nothing else is possible beyond this. No further factorization. So this is the final answer. So we can continue working further. So our answer is here. We go to the next one. It says quadrilateral ABCD is a rhombus. So we prefer taking one rhombus. We make one rhombus here. So this may not look like a rhombus. We'll try here. So we have identified the rhombus here. The rhombus name is ABCD. So here we're writing A, B, C, and D. For our understanding, opposite sides are parallel in a rhombus. This and this is parallel. The first property. The second property is, in case of a rhombus, all sides are equal. 1, 2, 3, 4. All the sides are of equal length. That is done. If we talk about the angles, opposite angles are equal. This and this, A and C will be equal. Here B will be equals to angle D. And now we move on to the diagonals. So if you're looking at diagonals, then here we go. So I'm joining A to C, we joining B to D. In case of a rhombus, the diagonals are not equal, but the diagonals are perpendicular bisectors of each other. So we know this is perpendicular. We're looking at perpendicular here. This is making 90 degrees and the bisectors of each other, which means this, if this was O, OC and OA would become equal. OB and OD are going to be equal. So this is diagonals are perpendicular bisectors of each other. And in case of a rhombus, the diagonals bisect opposite angles. So this and this angle would become equal. This and this is equal. This and this is equal. The same thing happens here as well. Now we want to find these angles. Here it says if BCA is 35, BCA is 35. This is 35. And it's saying how much is ADC. So BCA was here. ADC it is expecting. ADC is here. And the other piece that we want is BAD. 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 So we will have to use properties of the rhombus. So we start with the diagonal property. Our solution is here. The first thing that we want to state is angle BCA is equals to angle DCA is equals to 35, and the reason for this is the diagonals bisect opposite angle. Diagonals of rhombus bisects opposite angles. This is the first thing, angles. We move to the next. So we have realized that this angle of ours is 35 degrees. So we're using red color here for this. So this is 35 degrees. Now we were interested in angle BAD. BAD is this whole thing. So we know opposite angles of the rhombus are equal. So our second statement is angle BAD is equals to angle BCD is 70 degrees, and here opposite angles of a rhombus are equal are equal. So we got the first piece here. Now we are looking at ADC. When we say ADC, we are talking about this angle. Now we know that this AD and BC are parallel. If this is 70 degrees here, this would become 110 because coincident angles are supplementary. So here in this case, we want to write third statement, AD is parallel to BC, opposite sides of the rhombus, opposite sides of the rhombus are are parallel, are parallel. So this is done. Now the fourth statement is here. Angle ADC, angle ADC plus angle BCD is 180 degree because co-interior angles are supplementary. Since lines are parallel and cut by transversal, so co-interior angles are supplementary. Supplementary, supplementary. Done with this. But we have already figured out BAD, or rather BCD is also there with us. So therefore angle ADC plus 70 is 180. Therefore angle ADC is 180 minus 70, which is 110 degrees. So we have figured out ADC as well. So what we want to really do is, let's highlight this. It's not looking nice. So we can highlight this. ADC is here. ADC is here. ADC we figured out. So we have highlighted. BAD also we figured out. So BAD is also highlighted here. First one done. We move to the next one now. A train is moving with uniform speed 120 km per hour. How far will it travel in 36 minutes? So this is technically a unitary method which is directly proportional, because more the speed, it is asking us uniform. A train is moving with uniform speed 120 kilometers per hour. So here we are talking about the first part. So here we know the distance is, because the speed is given, we are expressing this as distance and time. So distance is 120 kilometers it travels, and the time taken is 1 hour. Since they're talking about minutes, so hour can be changed to minutes. So it becomes 16 minutes. Now we are looking at in 36 minutes what happens. 36 minutes, what happens? 36 minutes, what would happen? So this is the question mark here. If we travel for more time, we will naturally cover more distance. If we travel for less time, we will naturally cover less distance. So here the time is reduced. So this is going to be directly proportional. So we are looking at this falls down. Even this has to fall down. Less the distance, less time is taken. Let's call this as x. Therefore, 120 times 36 is x times 60. So we know 60 times 1, 60 times 2. So therefore, our x is 72 kilometers. How far will it travel in 36 minutes? It will travel 32 kilometers in 36 minutes. We go to the next part. How much time would it take to cover 300 kilometers? So we knew the same piece is going to be useful here. So we have got this piece of information. So here it is asking us how long would it take 300 kilometers. Naturally, more the distance, more is the time taken. So we want to call this as y. So here in this case, if this reduces, even this will reduce. It is directly proportional, so we will do cross multiplication. Therefore, we will get 120 times y is 300 times 1. Our y will be 300 over 120. So 0 is lost here. 4 times 3. We are dealing in terms of minutes only. We should have dealt in minutes. So we'll work it out in minutes here. So instead of 1, we will work with 60. Instead of 1, we'll work with 60. So 60 is here. So we know into 60 will be here, right here. Now we could change it and do it again. So this is 300 times 60 over 120. So 160 times 2 is 120. 2 times 1, 2 times 150. So this becomes 150 minutes. Here it says how much time. We can leave the answer as 150 minutes or we can convert it into hours. If you want to convert it into hours, therefore time required is 60 plus 60 makes 120 plus 30 is left. So 2 hours and 30 minutes is what is needed here. We move on to question number 5. Question number 5 says factorize. So our solution is, this is 108 x square minus 243 y square. So whenever we have the variable is squared here, and there's a minus sign here, you have to think, or rather we have to think in terms of difference of square identity. So the difference of square identity is here. A square minus b square would mean a plus b times a minus b. Is the case with us. So here in this case, it's not directly obvious that this is the difference of the square identity because there are numbers here and they're not looking like a perfect square. So our endeavor is to pull the common element out. So if you realize 8 plus 1 is 9. So this number is divisible by 9. 4 and 3 makes 7. 7 plus 2 is 9. Again, this number is divisible by 9. So we could go ahead with 9, but we will try a little more. If we go ahead with 9, we will write 9 out here. 9 is out. Now I'll be left with 12. 12x square minus 9 9 times 2 is 18, 63. 9 times 7 is 63. So y square is here again. So here in this case, we realize that this is still divisible by 3 and even this is divisible by 3. So we'll pull that number as well out. So we have 9 times 3, we are left with 4x square minus 9y square. And here we realize that 4 is a perfect square, 9 is perfect square, and there were squares already here and there's a minus sign. So difference of square identity is applicable here. So we continue writing equal to here. So we write 27 times 2x the whole square minus 3y the whole square. So we have this. We'll continue solving this further. So this is 27 times 2x plus 3y, and here is 2x minus 3y. So this was one way of looking at it, but I'll give you one more insight in terms of if you are not able to comprehend that 27 could be the common factor out. So you could go with whatever you could comprehend. So the easiest to go with here was by pulling the number 3 common out, because that is quite obvious in this case. So we will write this identity here. So here in this case, the most obvious common factor that comes out is 3. So we'll write 3 out. We'll be left with 27. 3 3s are 9. Rather, we'll be left with 36. 36 x square minus 3 was out, 81 y square. Obviously, these are perfect squares, 36 and 81. So we could apply difference of the square identity. So this would become 3 times 6x the whole square minus 9y the whole square. So here in this case, we have 3 times 6x plus 9y and 6x minus 9y. Here it is very important for us to realize that 6 is 2 times 3 and 9 is 3 times 3. So 3 is a common element that could be pulled out here and here as well. So we are going to write is equals to 3 times the number that we are pulling out common from the first bracket. We are writing it in this color, and then when we continue, 2x plus 3y multiplied by the number that comes out common element is from the second bracket is 3 is out here, and we continue solving this, 2x minus 3y. So here, because these are just numbers, 3 3 3, they could be multiplied and could be written as 27. So we have 27 times 2x plus 3y, and this is 2x minus 3y is here, right here. So this is done. We are looking at B. In a single throw of a dice, find the probability that the number will be an odd number. So when we throw a dice, we will write the sample space or all possible outcomes. So our solution begins here. So all possible outcomes, all possible. We could write this as sample space or all possible outcomes. Outcomes would in this case be 1, 2, 3, 4, 5, and 6. Remember, this is the roster form in set theory. So we prefer writing the elements separated by commas in curly braces, which indicates that we have made use of set theory. This is the roster form of writing the elements of a particular set. So this is a set, so we're using roster form. Here it says will be an odd prime number. So we should know odd and prime also. So we knew that this is prime 2, 3, and 5. We are not looking at 2 because that's even. Odd prime we're looking at. So we're looking at the favorable outcome. So here also we could use the same formula for probability, which we have used earlier up right here. Probability of an event. So we are making use of this outcome again. So we copy here. So it becomes easier for us. This is here. So for the first case, we are writing for the first one here. So we know our prime numbers. We should have written the prime numbers first and then written this outcome here. So we are writing prime numbers here. So our prime numbers, and that to odd prime number. So we will write favorable outcome. Favorable outcome. What we are expecting is odd prime number. Odd prime number. Our odd prime numbers are 3 and 5s only. So our probability in this case is going to be 2 over 6. We can't leave the answers as 2 over 6. We will have to make it 1 over 3 because all fractions must be in reduced factor form. So the first part is taken care of. Then we move on to the second part. Second part, it says will be a multiple of 2 less than 6. So our favorable outcome, which is number, not number, it is a multiple. So multiple of 2 less than 6, less than 6 would become in the set theory format. So multiple of 2, we want multiple of 2 less than 6. So we'll get 2, we'll get 4, and we have to stop there. So again, probability of any event. So we are looking at probability of a multiple of 2 less than 6 would be m over n, which is 2 over 6, which is again 1 over 3 is done, will be a factor of 4. We know 4 can be divided by 4, 2, and 1. So we are looking at factor of 4. So favorable outcome again comes into picture. Wherever possible, we will be required to write the favorable outcomes. Only if it is object like you're putting some 10 cards with some description over it, or you're putting 10 marbles, some are blue and some are green. In that case, you write the number of favorable outcomes is 3 or 6, depending on what the question is demanding. But here in this case, we will be required to write the favorable outcome. Without favorable outcome, the marking is supposed to be 0, will be a factor of. So we are writing factor of 4. Factors of 4 are 1, 2, and 4 here. So which means therefore probability of getting a factor of 4, of getting a factor of 4 is m over n, which is the formula which we have indicated. So which is going to be 3 over 6, which is 1 over 2. So we have written all the answers here. The first answer, so our first answer is here, the second answer is here, the third answer is here. We move ahead. Before we come back to this question, let's move on to another question, and we'll come back at the end so that we could save time. Here it is asking us to factorize again. So our solution, first thing is, we have to observe this is 3, this is 3 times 4, this is 3 times 5. Obviously 3 is a numerical factor that can be pulled out straight away common. So we'll have 3 out. We have what? X squared minus 3 4 the 12, 4x 3 5 the 15 minus 5, which is going to be 3 times. Now this is quadratic in nature, so product is 5. It's a negative product. That means one number is negative, the other is positive. The sum is a negative 4, which indicates that the bigger number is going to be negative. So here we know 5 times 1 is 5, and 5 minus 1 could give us a 4, but we needed a minus 4, so we'll take minus 5 plus 1. So we have x squared minus 5x plus 1x minus 5 sitting here again. So which is going to be 3 times x out, x minus 5 plus 1 out, x minus 5. So we left with 3 times x minus 5, and the other factor is x plus 1. So these are the factors that we have produced here. So we have fully factorized the given question. So factorization is done here. We move on to the next one. It says solve. When it says solve, it technically means we are required to get the value of x. So again, we could treat this fraction as we pull it out common, and we'll have to look at the LCM. So let's go with the LCM process here. So our solution is here. So we know that this x has got a denominator 1. This 1 also has got denominator 1. So the denominators that we're looking at is 1, 2, 1, 3. So the LCM is 6 in this case. So our LCM is 6. So we multiply each term with 6. So we're multiplying this with 6. We're multiplying this with 6. We're multiplying 1 with 6. And we're multiplying this with 6. So now we know cancellation is possible here. So 2 times 1, this is 2 times 3. This is 3 times 1, this is 3 times 2. So we have got rid of all the denominators. All the denominators are rather 1. So now we have to be very careful. The reason behind that is there's a minus sign here, there's a minus sign here. There's a huge potential of making mistake, which we should control. So we have, therefore, 6x minus 3 times x minus 1 is 6 minus 2 times x minus 2. So we should ideally write this multiplier 2 before the bracket so that the minus sign is applied with this minus 2, with this 2. So we don't make mistake here. The chances of making mistake will be highly reduced. Therefore, 6x minus 3x plus 3 is 6 minus 2x minus minus is plus 2 times 2 makes 4 plus 4 is here. So we continue solving here. So we know here 6x minus 3x would make just 3x. So we'll pull the 2x on the left. So therefore we have 3x plus 2x is 6 and 4 makes 10. 10 minus 3 would make us 7. So therefore 5x is 7. Therefore x is 7 over 5. We've got a choice of straight away dividing, or we convert this fraction into a decimal fraction by multiplying. It's 2 here and 2 in the numerator as well. So this would look like a 14 over 10. So this is a decimal fraction, which my result is going to be 1.4. 1.4 is the result here. So that is taken care of. We have to look at parallelogram ABCD. We will do this with a little more patience. So let's have the parallelogram here. So we are looking at parallelogram. All right. So this is setting here. So here it says ABCD is a parallelogram. So I could make it a little longer here. So we have A, B, C, and D. So E is the midpoint of AB. So we have E sitting here, right in the middle of AB. E is the midpoint of AB. So we mark this. And then it says CE bisects angle BCD. CE, we join this and it is bisecting here. So this is bisecting. The CE bisects angle BCD. So we know this angle of ours and this angle, they both are equal. BCD is getting bisected. Then it says prove AE is equals to AD. So our endeavor is to prove AE is equals to AD. So these two sides are required to be proved equal. Then DE bisects angle ADC. So we are also looking at this bisecting this, these two angles to be equal. Then we also need to prove this is 90 degree, the last part here. So let's go step by step. So here our construction bit should say our solution begins here. We are starting with construction. Our construction is simply join DE. DE is what we're looking at joining. And thus, therefore, we are looking at making this as the line here. We're joining this. We join DE. Now our job continues here. All right, our first job is to prove AE and AD equal. AE and AD equal, which means this triangle should be proved isosceles. The method of proving this is we may use a in a way isosceles triangle property or some connection that we have already have the equality given here. So let's continue our process. So here we want A is equals to AD. So let's start here. So our first step is, since we know CE is the bisector of BCD, so we want to say angle BCE is equals to angle DCE, and which eventually we want to call them as XX each, X degrees here. So we will say given, what was given? CE bisects angle BCD. BCD is done here. Then we go to the next piece. The next piece here is, since we have called them XX, so we are noting them down here, X and here X. So since we know it is a parallelogram, so opposite sides are parallel. So the second statement is AB is parallel to CD, and we may also write AD is parallel to BC, and in one go we'll write those reasons here. Opposite sides of a parallelogram are parallel. We have done this. We have in a way stated that this line of ours, and this is parallel, just stated this. This double arrow with this double arrow, these two are also parallel. So since we know it is parallel, we can use the interior alternate angles are equal property. So here we want to state 1, 2, 3. We want to say that angle DCE is equals to angle DCE is CEB, angle CEB, which is going to be called as X, and the reason for this is interior alternate angles are equal. So this is taken care of. So we have got this angle as X. So now it's quite obvious that triangle BEC is become isosceles. So we want to write that statement here. So therefore, BE is equals to BC, and the reason for this is in any triangle, side opposite to greater angle is greater. In any triangle, the side opposite to greater angle is greater. The side opposite to greater angle is greater, or side opposite to smaller angle is smaller, or side opposite to equal angles are equal. So here we know these were equals. Therefore, in any triangle, we are writing sides opposite to equal angles. In this case, is equal angles are equal. So this in a way has become isosceles for us. We already knew the piece that is BC and AD are equal. AD is equals to BC, and this is opposite sides of a parallelogram are parallel. Opposite sides of a parallelogram are parallel. So this is, or rather we are looking at equality, so we will say are equal. So here we have understood that this is equal here. So now if you realize this and this has become equal, this and this has become equal, but we already knew BE and AE are equal. So in other words, all four of these are equal. So here we want to straight away claim that the sixth statement for us will be very, very important. Therefore, what we get here is AD is equals to AE is equals to BE is equals to BC. And to support this statement, AD and BC was already spoken here. AD, this piece here, and BC was already spoken here. So we were already told here BC and BE are equal. BC and BE are equal is here. BC is equals to BE. So we have been spoken about BC and BE. We don't have a mention of AE now, but AE is equals to BE was already given. So we could have, or we should have stated this already here. So we are going to be feeding that information here, because what was given, we should have used it earlier itself, but it's still okay. Now, using this information here because you're feeding at the end here. So this is statement number 6. Here we are saying AE is equals to BE. The reason for this was given. So now we have all the statements to support our argument number 7. This is our argument number 7. So we will have to state here the statement reason is from 4, 5 and 6 statements. These are the statements that we have used to arrive at this particular conclusion. So we now know AD and AE are equal. So we were more interested in AD, which is here, and AE, which is right next to it. So these have become equal for us. So we want to use this information to go ahead with our further claims here. So the first part gets completed basically. So eighth statement, we are just stating the fact that we have done so far. Therefore, AD is equals to AE, 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 hence proved. Here we can write, hence proved. Now we'll go to the next part here. DE bisects angle ADC. DE bisects angle ADC. So now our next line here begins with 8 and this is ninth. We want to say, since we know that this side and this side they are equal, so base angles will become equal because it's now isosceles triangle. So we're going to write that. So therefore, angle ADE is equals to angle AED. We have to call it as y degrees. And the reason for this is base angles of an isosceles triangle are equal, or we could say angles opposite to equal sides are equal. Let me say angles opposite to equal, angles opposite to equal sides are equal now here. So we have got them as y. We just putting that particular statement here. This is y, and even this is y. But we have already stated that AB and CD are parallel, so we could straight away go ahead and use alternate angles property here. So we're now going to be using alternate angles property 9, 10. 10 statement is, therefore, angle AED is equals to angle EDC is equals to y degrees, and the reason for this is interior alternate angles are equal. Interior alternate angles are equal. Interior alternate angles are equal. So we have got this angle as y. So we have proved this part now. Therefore, DE bisects angle ADC. So statement number 11, now we want to state, therefore, DE bisects angle ADC. DE bisects angle ADC. So here also we can put the statement as hence proved. Hence proved. So we go to the next part. Here it says DEC is right angle triangle. We have already stated AD and PC are parallel lines. So we want to go ahead and use this further. So statement number 12, we will say angle ADC plus angle BCD together makes 180 degree. The reason for this is co-interior angles are supplementary. Co-interior angles are supplementary. If we don't write co-interior angles, we could write conjoined angles. We could write allied angles are supplementary. But we already know that ADC is 2y. So we will say, therefore 2y, BCD was 2x. So 2x makes 180. If we divide each term with 2, and we just show it here, dividing by 2 here, divide by 2, divide by 2, this will obviously look like, therefore, y plus x makes 90 degrees. So we have already got one more statement here, which is going to be very helpful to us. We move to the next part now. That is statement number 13. We are saying in triangle DEC, we want to say y plus angle DEC plus x together makes 180 degree. The reason is angle sum property of triangle. Angle sum property of triangle, of triangles. But we already knew x plus y was 90, therefore 90 degrees plus angle DEC is 180 degree. Therefore, angle DEC would become 180 minus 90 degree. Here is 90 degrees. So the last piece is also completed here, that the angle DEC is 90 degree. We proved it is right angle. So here our final statement is also needed. So what we could do here is, I could move just a little ahead here. So we go here. So we are here. So final statement here. Therefore, angle DEC is a right angle. Is a right angle. So for all word problems, answer statement is a must. So we have done this. We have done this part here. So now we are required to do a bit of construction as well. So for construction, we will have to use some third party application. So